estimated to be 4.5 billion years old and weighing 5.9 trillion kilograms, Earth is hurtling through space at a staggering 66,000 miles per hour. While there are many planets of a similar size and distance from a star, there may also be other planets with a similar temperature and maybe even a similar atmosphere. Earth is different from the others though, as it is the only known astronomical object that supports life. Our planet is estimated to support between 10 to 14 million different species of life, from tiny single-cell organisms to massive blue whales. However, planet Earth is home to one particularly interesting species, and it's not because of their numbers, nor size, nor weight. Planet Earth is home to 7 billion humans. Even though humans have only been around for 500,000 years, the population is widespread and has altered the Earth more than any other species that live on the planet. The population has doubled in the last 50 years alone. As a result, they've got a huge impact on the climate, the environment, and other species. More people means more demand for food. More demand for food means more demand for space to grow the food, and more humans means more demand for space to shelter the humans. In areas of the world that was once home to many species of animals, has now become populated by humans. Approximately 124,000 square miles of forest are now removed every year. That's an area twice the size of the UK, and sadly the impact on the world's wildlife is catastrophic.
Using unique technology engineered by Leonardo, scientists and conservationists are now able to investigate wildlife and attempt to understand how big the problem is, how many animals are actually affected, and in what way. To do this requires that we are very careful not to disturb the animal's natural behaviour, which might sound simple, but sometimes just trying to locate, count, or even just catch a glimpse of some animals is a lot harder than it seems. Animals, especially nocturnal ones, have developed better senses than humans. Human eyes and ears are a lot less sensitive than animals. Most wildlife is typically very sensitive to humans, with sensitive hearing to prevent anyone from getting too close or being able to find them. Some owls have also developed incredible vision like the owl. Did you know an owl's vision only needs about 1/100th of the light humans need to see, making it possible for them to fly silently in low light and at night time without bumping into a tree? A camera like the one on your mobile phone could be used to look at animals in visible light. But at night time, cameras aren't very good. Using a big light or the flash might help the camera to see. But the problem is, animals don't like that and realise someone's watching. Now, to understand how light works, let's have a look at the electromagnetic spectrum. This helps us describe the differences between what is visible and invisible to the human eye. Visible light we can see with our own human eyes. It's different to X-rays used to see broken bones or radio waves that carry music and speech across the planet. To make it possible to detect animals at night, we use incredible electro-optical, EO for short, technology, which is capable of seeing the IR or infrared part of the spectrum. Infrared is a type of radiation that's emitted by something hot, but human vision can only see high thermal energy such as bright light or heat from a fire. Now, to help humans see in the dark, Leonardo made these amazing infrared cameras which detect tiny differences in temperature down to fractions of a degree. That's so cool! Many living creatures, just like humans, emit thermal energy or heat. And even if a species is cold-blooded, it will be a different temperature to its surroundings. So, in the dark, these animals can be easily detected. Using Leonardo's cameras with zoom lenses allows scientists and conservationists to record amazing high-definition images and video of animals, even in the pitch black of night from a long way away. Did you know that Leonardo's thermal cameras can detect an animal over 30 miles away? If you were driving through town, that would take you an hour to travel that far. And remember what we said about animals having great hearing? They would hear your vehicle engine and run away. Conservationists and study groups use these high-definition, never-before-seen images to closely study wildlife and species of animals discreetly and naturally.
Hi guys, my mission is to gather as much data as possible. I'm having some trouble accessing some of my memory modules. Do you think you can help me with some of the data I was collecting? What does IR stand for? Let's try another question. What range can Leonardo's cameras detect animals from? Just one more should help me make the connection. What does EO stand for? Wow, I am ready to analyze some more data.
Humans have not only made an impact on animals which share the planet, but also on the atmosphere. Since the early 2000s, scientists have been tracking cases of extreme weather across the planet to help us understand the environmental change and how human activity has contributed to this. Extreme weather can be described as significantly different from usual, including flooding, droughts, storms and heat waves. The extreme weather can have a devastating impact and cause life-threatening situations.
Studies have indicated that the most recent extreme weather events were likely to have been more severe due to human activity having an impact on climate change, leading to an increase in rainfall and flooding. Now, that doesn't sound good to me. As an example, a common extreme weather event in the UK is flash flooding, where extraordinary amounts of rain fall very quickly, causing an area to flood. Events like these are often hard to accurately predict. To help scientists and meteorologists study and understand these weather phenomena, we can use technology in the form of radar. Do you remember the electromagnetic spectrum? Radar stands for radio, detection, and ranging, and uses low-frequency electromagnetic radio waves. And they travel at the speed of light. To put it into perspective, that's 300 million meters per second. Literally, blink and you'll miss it. So they can be used to detect an object which is really far away. Radar technology works by sending out a regular pulse of radio waves. Then it listens for a return which is caused by a radio wave signal bouncing off something back towards the radar. That signal is received and can be measured. The information in the data can then be used in a number of ways, depending on the signal and the object detected. Meteorological radars can be used to detect the density of water in weather systems, such as clouds and rain. The measurements from the data work out how fast the weather system is moving and even which way it's going. The data can also indicate if the weather is warm or cold, producing rain, hail, or snow. Crazy stuff. Did you know there are currently more than 400 Leonardo weather radar systems in over 80 different countries, helping scientists in Scotland understand the weather in Norway? But to see even further with a radar, you need to be higher in the sky. Leonardo's helicopters need to use very complex radar systems which can detect weather, not only to fly safely, but also to save lives. Finding tiny boats lost out in stormy seas, 100 nautical miles away. Leonardo also make unmanned aircraft, which allow our incredible sensors to fly without a pilot. And no, I'm not joking about that, it's real. And by plotting a course using our control systems, we can fly exactly the same route over and over, collecting more and more data about environmental changes. We can then use the data to examine and measure any changes, which help indicate the impact of extreme weather and even deforestation. This includes landslides, the effect of tremors, earthquakes, even volcanoes. As responsible protectors of our planet, we have to remember that all of these threats don't just affect humans, they affect all of the Earth species, so we've got to look out for them. Using our sensors, people are able to act quickly if disaster strikes, and over time, the data and information can be used to help protect us all, and even predict future events. It's almost as if we're psychic.
Even more amazing data I need to analyze. But do you think you can help me check if my memory modules are working? What is the name of the technology which is used to detect weather systems? Okay, what about another question? What part of the electromagnetic spectrum is used with that technology? Do you think you can try just one more question? How many nautical miles away can an aircraft detect an object at sea? Oh, thank you.
About 20% of planet Earth is covered in vegetation, such as forests, fields and grassland. Unfortunately, 20 years ago, scientists started to see that percentage beginning to decrease. And now about half of the planted areas on Earth are suffering from a reduction in plant growth, according to Scientific American. In the UK, less than 10% of the country is covered in woodland, according to Britannica.com. And they also state the survival of wild mammals, amphibians and reptiles of the United Kingdom depends on their ability to adapt to changing environment and to protect themselves from attacks by their enemies. The most dangerous of whom are human. In order to understand the level of vegetation of an area, scientists must survey the land. This can be done by land vehicle or better still, in the sky. However, for us to see bigger areas of our planet, we need to go to space.
For many years, Leonardo has developed amazing technology, making sensors so complex they have to be made in laboratories, which are cleaner than a hospital operating theatre. A secret recipe of chemicals and technology helps Leonardo scientists and engineers create incredible detectors and sensors. We carefully control the environment the detectors are made in, freezing them with liquid nitrogen, and using technology to create a vacuum to remove any trace of air. Only then can our detectors be placed into systems which are carried by satellites used to study our planet, observing Earth from space. As the satellites fly around the planet, they collect data, which scientists can use to understand changes to heat, water, and population levels. Leonardo sensors continue to help scientists and will soon support the study of photosynthetic activity of vegetation on a global scale. The data collected provides valuable information on plant health in a changing climate. In 2024, our Flex detector system will be the very first sensor of its kind in space, giving scientists a never-seen-before view of planet Earth's vegetation. Even better, the data collected will be available to anyone for free. The Flex detector will collect the light emitted by plants and break it down into its constituent colours. The sensor can then identify the faint reddish glow emitted during photosynthesis, normally invisible to the human eye, allowing researchers to measure the health of Earth's ecosystem. On our electromagnetic spectrum, the satellite sensors use the portion that is the most common to humans, visible light. The data collected from the satellite provides scientists with details of the type of terrain and its vegetation levels, and over a period of time, they will understand how it is changing, or is being changed by humans. This includes changes in the natural landscape and farmland where crops are grown. Remember earlier, we said that increases in human population results in increased demand for land and food. Leonardo's sensors are travelling even further into space, monitoring asteroids, the stars, and other planets. In fact, right now, Leonardo's detectors are exploring Mars.
Wowee! Space is my favorite place to be. But can you help me send some data? How clean are the laboratories where the detectors are made? Okay, what about this? What chemical is used to freeze the detectors before going into space? Just one last question. How much will the space data cost? Well done, guys. Now let's see how many questions you managed to answer correctly. Well done. Did you get that one right? Good job. Hi guys, my name is Jason and I'm the voice behind the robot. And in fact, I'm actually a real employee of Leonardo. When I was in school, I liked gaming and IT, and I always wanted to get a job in IT. The idea of protecting data sounded really appealing to me, and that's why I took an apprenticeship with Leonardo. Leonardo has helped me to grow my career, and I've managed to see many things which I would never have if I had to just go to university. I wish everyone the best of luck on their future mission.
Hi, I'm Ellen and I'm a second year technical apprentice. I was talking to you about Leonardo's thermal imaging cameras. When I was at school, my favourite subjects were physics and art, and in the future I want to become an engineer. I just want to wish you all good luck on your future mission.
Hi everyone, I'm Seb. I'm a product support engineering graduate for Leonardo helicopters. I was the disembodied voice talking to you about radar and the environment. So when I was at school, I really liked subjects like physics, chemistry and maths. And when I was smaller, I really wanted to be either a rock star or an aerospace engineer. So I'm living one of my dreams. And I came to join Leonardo through the graduate scheme, and it's absolutely amazing. I get to see aircraft every day, I get to see helicopters flying around, and I sometimes get to go in them. So I just wanted to wish you luck on your future mission, whatever that is.
Hi, my name is Anna, and I was talking to you about the observations from space. I'm a second year graduate electronics engineer at Leonardo. My favourite subjects at school were maths, physics and music. I studied electronics and electrical engineering at university and knew I wanted to create amazing solutions in the world of engineering. When I saw the graduate programme at Leonardo, the world of radar sounded so fascinating, and I've enjoyed it so much ever since. I wish you all the best of luck in your mission and hope you have loads of fun.
Hello, my name's Catherine and I'm a real life employee of Leonardo's, not the voice of planet Earth. In school I really enjoyed maths, physics, chemistry and biology, and I thought I was going to grow up to be a professional magician. However, I'm now studying aerospace engineering at Coventry University, and I've taken a year out to find more about what it's like to be an engineer with Leonardo, and I'm thoroughly enjoying myself. Good luck for the future!